All right, guys, I wanted to give you a little heads up on how to use the TI-84 or 83 graphing calculator to find correlation, coefficient of determination, and line of best fit or least squares regression line, whatever you want to call it. So I've got my TI-84 here, and we're going to try to put in the data that we have and then see if we can figure out those things. So the way to put in the data that you have is going to be right here under this menu. Basically, all this is going to be under this button. So I'm going to hit Stat, and then the very first one here is Edit. I'm going to hit Edit on there. And then this is where you're going to put in the data that you have. Now, I'm going to put in just random numbers, basically. And so I'm going to type in some numbers. This is where you'd put your lists of data. All right, so let's say we've got those 12 numbers. And then I'm going to go over to list 2, and I'm going to put another set of random numbers. All right, and then we have to make sure we have the same amount of numbers in each group because really each of these things represents an ordered pair. So whoever had 8 of whatever's in list 1 had 12 of whatever's in list 2. So once we have that stuff in, I'm going to go back to the Stat menu, and I'm going to go over to Calculate at the top. And then I'm going to go to the fourth one down, Linear Regression AX plus B. So when I go to that, I'm going to get something that looks like this. Now, if you have an older calculator or one with a different operating system, it'll just come up and say linreg, and that's it, basically. It'll just come up with something like that at the top on your regular home screen. It automatically does list 1 and list 2 as your X list and Y list. The only way you have to change anything here is if you put your list somewhere else. And so if you just hit Enter and go down to Calculate, it will tell you your least squares regression line or line of best fit. And so the line of best fit would be y equals 0.178, we could say if we round it, plus 4.26. And so basically it's y equals ax plus b. Just put in that for a and that for b, and that's your line of best fit. Now, the other thing that we need is we need r and we need r squared. We need our coefficient of determination and we need our correlation coefficient. So to get those to come up, there's a weird thing you have to do the very first time you try to do this on one of these calculators. This is going to be a one-time thing. After we do it this time, you'll be good. Follow along because there's quite a few buttons and things we're going to have to push here that are not your normal things. So what we're going to do is we're going to go second and then catalog. Right down here, the 0 button, second catalog. And this will give me the list of everything the calculator can do. Now, we want to go down to one that's called diagnostic on. You could scroll down for a really long time, but if you just hit the D, do you notice all the little green letters above the keys? Since that starts with D, if I hit that, it'll jump me down to the Ds. That way I don't have to do quite as much scrolling down. And so I'm going to scroll down until I get to the one that says diagnostic on. So there it is. And then hit Enter on that. It'll put it on the home screen. Hit Enter again, and it's turned on now. So once this is turned on, what we're going to do is that same thing we just did. So I'm going to go Stat and then Calculate Linear Regression AX plus B. So that fourth one down, and still using list 1 and 2. So this is the exact same process we just went through. But now since I turned that diagnostic on, when I do this, it's going to give me A and B, but it's also going to give me R and R squared. And so we have our line of best fit plugging in A and B in that equation, but now we've got R, and remember R is our correlation coefficient, which is like 0.14 approximately in this one, which would be a very weak positive correlation. And then R squared is 0.02, and remember that means that about 2% of the variability in the one could be explained by the variability in the other, depending on which one's independent and dependent. We could make a sentence out